Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Non-Combustible Façade Engineering. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them, their cultures and to elders, past, present and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's long-standing industry partner, Brickworks. Brickworks Building Products is one of the world's largest and most diverse building material manufacturers. The company has built an enduring reputation with its customers and it's loved for its innovation, professionalism and dependable products and services. With a broad product portfolio and manufacturing and sales facilities across Australia and North America, Brickworks is uniquely placed to service the demands of the building industry.
Throughout the past 110 years, the face of building materials has continued to evolve. We're here for a lifetime of living. This is Brickworks. More than brick, and more than just building products, we are a foundation for today's lifestyle and a leader for today's style. We manufacture a wide range of building products. Products like no other. Local and international innovation. Sourced from around the world to exceed customer expectations. Distinctive and luxurious products. Beautiful products that stand the test of time. Building inspiration and innovation with an unmatched standing of style. This is Brickworks.
Today we will hear from two speakers, followed by a live audience Q&A, and as always I encourage you to send questions through to our speakers via the chat box. And I'd like to welcome our first speaker, Doron Levy. Doron is the proprietor and general manager of Fahrenheit Fire Engineers, trading as Fahrenheit Global. Doron has 7 years international experience working in a European fire engineering consultancy firm and an additional 18 years of local experience. Over his 22 years in the building consultancy environment, Doron has worked in most fire protection areas including cladding assessments, fire safety consultancy, maintenance inspections, commissioning, performance-based fire engineer solutions, fire safety system design, BCA compliance inspections, audits on mine sites around the country. Please welcome Doron Levy.
Thank you, Amanda, for that introduction. Last April, when Engineers Australia emailed me an invitation to speak at an upcoming Thought Leaders event on the topic of non-combustible facade engineering, at first I was surprised. What else can be said on combustible cladding that hasn't been discussed in numerous facades and cladding seminars held around the country? For example, I'm sure many of you attended Tuesday's New South Wales Project Remediate discussion on the Accor Engineers Pattern Book. And then I was honoured to have the opportunity to present to the broader engineering community on a topic that has been at the forefront of facade, structural and fire engineering consultancy firms for over a decade. During this presentation, I'll try not to discuss items that were raised yesterday. In developing this presentation with other engineers in my firm, we noted that the introduction shouldn't start in the same way that we have heard many others present on this topic, by raising historical cladding fires like the Television Culture Centre Tower in Shanghai in 2010, La Crosse Docklands, Melbourne in November 2014, the Torch Tower in Dubai 2015, the APCO Tower in Sharjah in 2020, and only this month, the Grand Satan Plaza Business Center in Moscow in June 3rd, 2020. The reason I did bring up this short list of combustible cladding fires as examples of the many others I found during my research on the topic is the fact that this week is exactly 5 years to the day that we witnessed the Grenfell Tower burning in early hours of the morning, June 14th, 2017. So I thought it appropriate we stop for a moment to remember the 200 plus innocent victims of all cladding fires from around the world. The issue of residential fires featuring combustible cladding as highlighted in 2017 by the devastating fire at Grenfell. However, the history of the type of fires goes back further than to June 2017 and is an international crisis. How did we get here? Polyethylene cord aluminium sandwich panels, commonly known as aluminium composite panels, ACP, PE or PU panels, were developed over 50 years ago. ACP was originally introduced as a joint intervention between companies known as Aslugen, a German aluminium manufacturing plant, and BASF, a German multinational and the largest chemical producer in the world, in 1969. Later, AluSwiss, a Swiss industrial group founded in 1898 in Zurich, bought Alzigen, which was eventually obtained by another international firm named Alcan, currently Rio Tinto, in 2020. In spite of its introduction in the 1960s, it was only until the mid-1980s that the mainstream architectural industry discovered the proprieties of ACP as a building material and started its extensive use. Moreover, the widespread use of ACP in commercial and residential buildings began in the early 1990s. It was then realized that it could reduce costs and enhance architectural performance. Patented in 1917 and marketed as a Lucabond, when the patent expired in 1990, other manufacturers entered the market. It was estimated that there are currently over 200 manufacturers around the world, not all supplying to the Australian market, however. By the 1990s, ACP was the go-to cladding material for facade engineers and architects, and has become a standard material for medium and high-rise buildings across Australia. It revolutionized the building sector by providing a low-cost, aesthetically pleasing skin or layer that was easy to attach to a building framework. Benefits of this cladding including its ability to stop rain entering a building, sound and thermal insulation, as well as fire resistance. How did we get here? Aided by changes to the Building Code of Australia by way of the introduction of performance requirements, replacing a blanket ban on combustible materials being used on tall building facades. The timing and the relaxation of the Building Code and the introduction of ACP to the Australian market by multinational companies could be a coincidence. However, as outlined in my introduction, by the end of the 1990s, there was a growing evidence that the performance-based approach to facade engineering was not working. Combustible core sandwich panels were implicated as contributors to serious injuries and deaths. In the aftermath of the scores of flammable cladded building fires from around the world, questions are now being asked regarding the viability of cladding and the potential impact across Australia, given a significant increase in multi-dwelling developments. In response to September 6, 2017, the Australian Senate Economic Reference Committee released its interim report on aluminium composite cladding, which included the following 8 recommendations. 1. The Australian Government implement a total ban on the importation, sale and use of polyethylene core aluminium composite panels as a matter of urgency. The Commonwealth Government work with state and territory governments to establish a national licensing scheme with requirements for continued professional development for all building practitioners. The Building Ministers Forum, giving further consideration to introducing national consistent measures to increase accountability for participants across the supply chain. That the Commonwealth Government consider making all Australian standards and codes freely available. 5. The Commonwealth Government consider imposing a penalty regime for a non-compliance with an NCC, such as revocation of accreditation or a ban from tendering for Commonwealth-funded construction work with substantial financial penalties. The Commonwealth Government ensured that the Federal State Safety Commissioner is adequately enforced to ensure the office is able to carry out its duties, in line with the new audit function and projected workflow. The Commonwealth Government's decision to give further consideration to director identification numbers and recommends that it expedites this process in order to prevent directors from engaging in illegal Phoenix activity. The state and territory government worked together to develop a nationally consistent statutory duty of care protection for the end users in the residential strata sector. What has changed? The following table highlights some of the regulation changes carried out around the world over the past decade concerning flammable cladding use. In the United Kingdom, metal composite panels with an unmodified polyethylene core now cannot be used on any building of any height. The United Arab Emirates, aluminium composite panels cladding was prohibited in the UAE when the country's Fire and Life Safety Code of Practice was updated and made public in 2017. In the European Union, in line with the subsidiary principle, fire safety is a regulatory competence of the EU member states and addresses in national regional building codes. There are no common European-wide data or statistics on fire safety, so the Commission does not have any objective evidence about how widespread the risk in the European Union is. However, it is commonly known that the fire propagation through facade systems requires special attention, especially in multi-storey buildings. In 2018, the European Commission published a study taking stock of the methodologies in use in the different member states to assess the fire performance of facades. In context of the study, a proposal of European testing methods were developed. The US of A. The regulation for fire safety of cladding facades in the International Building Code, the IBC, the most widely used code and requirements in the US, are quite reasonable and are likely to lead to appropriate fire safety in such buildings. This is based on requiring fire testing of complete assemblies of each individual component. In Australia, the NCC 2020-22, Volume 1, contains several amendments to the fire safety of external buildings. This clarifies interpretation of concessions from non-combustibility requirements, also included as new provisions that prevents fixing of certain bonded laminated cladding panels by adhesive only. The NCC 2022. This will be discussed in greater detail in the next presentation by Cathy Inglis. So stay tuned for that one. It'll be interesting. States and territories agreed to delay the adoption of the National Construction Code, the NBC, BCA 2022, until 1st of September 2022. Fire safety of external walls. Volume 1 contains several amendments to the fire safety of external walls. This clarifies interpretation of concessions for non-combustibility requirements. A new provision that prevents fixing of certain bonded laminated cladding panels by adhesive only. Waterproofing. The new DTS provision in Volume 2 for waterproofing of wet areas, not previously covered by the ACP. Weatherproofing. Volume 1 contains additional DTS provisions providing new solutions for weatherproofing of external walls, including references to weatherproofing provisions in Australian standards for masonry, autoclaved aerated concrete, and metal wall sheeting. To the best of my knowledge, the 2022 version of the National Construction Code has presented numerous changes that could affect the compliance and performance requirements for building cladding and facade systems, as well as other construction materials and methods. In reviewing the draft NCC 1, I note that the Australian Building Code Board have taken an how we can make construction easier type approach by significantly adding more deemed to satisfy clauses, approving products and installation methods. Unlike previous codes, which were ultimately based on performance-based solutions to meet the performance requirements. For sarking, for instance, the advocate change to clause F3D3 implies that where sarking is used, it shall be used in accordance with AS 4200. For bonded laminates like ACP, there's a key new provision that prevents fixing of certain bonded laminated cladding panels by adhesive only, but this is unlikely to have much impact, as these requirements are already implemented in the Australian market by the main suppliers. In addition, the approval external wall cladding, in line with AS 1562.1, the design and installation of metal roof and wall cladding. It is known that waterproofing is the #1 defect affecting high-rise buildings, so the decision to assign waterproofing of wall cladding to a standard design for roof performance under wind loads, with no significant water or weatherproofing requirements, is baffling. For absolute surety, compliance should be built around system-based waterproofing and weatherproofing testing, not on wind load strengths. While not obvious in the revised codes, the requirement of the standard means it is only really applicable for large format roof sheeting products and not for the majority of metal cladding products used in high-rise facades. Fire resistance. Approving more materials agreed as non-combustible in terms of fire resistance simplifies the choice of construction products and materials and slightly reduces build and product certification costs. This applies to recladding and replacement of combustible cladding. What has changed? Here in New South Wales, the Design and Building Practitioners Act of 2020 is a key part of the New South Wales government legislative response to concerns about accountability and consumer confidence in the residential apartment sector. One of the main reforms of the DBP Act introduces is to extend the duty of care in tort to exercise reasonable care to avoid economic loss caused by defects so that it is owned to owners of apartments. This reform will encourage practitioners like myself to take individual and collective responsibility for their work and will provide owners with an avenue of recourse in the event of a defect during the building's life. The New South Wales Cladding Task Force has established to identify buildings with potential combustible cladding and support local councils to address the use of non-compliant cladding materials. The task force audited 180,000 building records, and to date, 4,182 buildings have been inspected. Of these, the government identified 1,000 buildings with possible dangerous cladding. To determine if cladding is present or poses a high risk, Fire and Rescue New South Wales, on behalf of the New South Wales Cladding Task Force, conducted an operational assessment of each of these buildings. Buildings considered a high risk were referred to the consent authorities, such as local councils and/or the Department of Planning and Environment, for further investigation. A significant number of these have already been cleared. As not all cladding is dangerous, there are a number of factors that were considered when determining whether cladding on a building may possess a higher risk, including a total coverage, vertical coverage, positioning around balconies, windows or doors, as well as the types of buildings and the way it is used. Buildings are considered cleared if they do not have cladding that the Fire and Rescue New South Wales considers increased safety risks. The cladding has been investigated and cleared by the consent authority. Unsafe cladding has been fully remediated. Results of cladding inspections. The Cladding Product Safety Panel provided expert advice to the New South Wales Cladding Task Force and the Cladding Support Unit on the suitability of cladding replacement, the products and external wall assembly methods. The Cladding Product Safety Panel members are made of expert trading in fire safety engineering, product testing, building certification, surveying, construction, and building insurance. On March 30th, 2021, the Cladding Product Safety Panel provided its initial endorsement of products and systems for Project Remediate. The report advises on appropriate products for replacement of combustible material and provides recommendations on how flammable cladding should be assessed and remediated. Of particular note is that the report endorses all flammable cladding should be removed, with no endorsement for remediation by alternative solution or fire breaks. Cladding should be mechanically fixed with no glue or double-sided tape fixing, as the report notes that in instances of repairs carried out on composite panels by adhesives or tape fixings, there can be potential risk of large pieces of panels, debris falling off a building in a fire of these materials, often softened below temperatures of 100 degrees Celsius. The Cladding Product Safety Panel's report provides expert advice only. It does not have any powers to ban the use of flammable cladding. The report provides advice to support the Cladding Task Force and Cladding Support Unit, which propose further advice to consent authorities, such as local councils, who assess the safety and compliance of buildings and issue enforcement rectification orders and determine the suitability of remedial development application, commonly known as DA. I'm sure most of you were present during yesterday's Project Remediate presentation on the forthcoming Accor Engineers Patent Book, so I'll keep this short. Project Remediate is a voluntary program to replace flammable cladding for eligible Class 2 residential apartment buildings. It offers a 10-year interest-free loan and assistance from experts. Financial support is available for eligible building owners. You will end up with a replacement cladding that is certified safe, long-lasting and insurable. Currently, Project Remediate allows for products which contains combustible materials of 8% or less of the cladding core to be retained, if strict requirements are met under the National Construction Code, in that the building avoids the spread of fire via its external walls and therefore meets the performance requirements CP2. The 8% rule of thumb. Composite panels containing more than 8% combustible materials by mass within their cladding core, such as polyethylene, PE, core is deemed medium to high risk and needs to be replaced. ACP panels with 8% or more combustible material will need replacing. Currently, the New South Wales product ban is only applicable to panels with combustible material of 30% or greater. It is likely that in the future there will be a second run of cladding replacement for 8 to 30% PE cladding. Therefore, owners corporations with such cladding may need to make financial provisions for its placement. Owner corporations with 8 to 30% PE cladding are likely to be slugged with increased insurance premiums and possibly even difficulties to obtain insurance coverage, due to the Insurance Council of Australia's deeming such cladding medium to high risk. Potential buyers of such apartments with cladding of 8 to 30% PE may be unable to obtain bank mortgages for such purchases, creating a problem for existing lot owners who are looking to be able to sell. Owners corporations that have already replaced extremely flammable PE cladding with cladding between 8 to 30% PE, as such claddings are not banned product under the Building Product Safety Act of 2017, may need to again replace the cladding and may not look at potential claims against building professionals that advised on the replacement cladding. Any building professionals who are advising on the undertaking cladding replacement should be aware that 8% is likely to become the new minimum PE percentage for cladding in the future. Only solid aluminium, solid material, fibrous cement, and non-combustible cement render are considered acceptable replacement options, subject to bespoke design requirements. Panels with less than 8% combustible materials will need replacing unless tested to AS 5113. In summary, building professionals should be aware that 8% PE cladding is likely to become the new minimum PE for future cladding and note this to clients when advising or undertaking cladding replacement. Be wary of any combustible cladding materials in excess of 8%. What has changed in Victoria? A ban on cladding deemed by the Victorian government to be high risk came into force in February 2021 in a bid to reduce high fire hazards. Multi-storey developments will not be able to use flammable aluminium composite panels or rendered expanded polystyrene. Penalties of $80,000 will apply to individuals and up to $400,000 for building companies. Victoria's Housing Minister wants a national approach to the issue of combustible cladding. Victoria's Minister for Planning announced at the time that flammable aluminium composite panels and rendered expanded polystyrene would be banned for use as external wall cladding for all multi-storey developments in the future. This ban will ensure new developments are built to the highest standard to keep Victorians safe, he said. The prohibited materials will not be allowed for use on apartment buildings, hotels, aged care facilities, and other residential buildings with 2 or more stories. The ban also applies to office buildings, retail premises, such as shopping centres, warehouses, factories, and car parks with 3 or more stories. ACP can be used if they have a core of more than 93% inert mineral filler, the 8% rule. In Queensland, the recent amendments to the Queensland Building and Construction Commissioning Act of 1991 have made it an offence for any person involved with the design, manufacture, import or supply of a building product to install a product when it knows or is reasonably expected to have known that the product does not comply with the relevant regulatory provisions, combustible ACP, is non-compliant with the Building Code of Australia and could fall foul of the recent amendments. A particular penalty under the amendments is the requirement that the offending party remedy the contravention by removing and replacing the ACP. The recent amendments may provide recourse for building owners to have non-compliant ACP on their buildings replaced. However, it may consider time for the proper investigation of who the reasonable responsible parties are and correct appointment of the responsibilities between multiple responsible parties before rectification occurs. In this intervention time, responsible parties such as body corporates run the risk of a catastrophic fire event occurring when they know of the relevant risk posed by the ACP. If those parties who are responsible for the design, manufacture, import or supply of the non-compliant ACP do not have an insurance cover, the building owner may still be left in the position where it needs to pay for rectification work itself. Additionally, the maximum penalty for failing to comply with an order to remedy the contravention is $1,260,000. These amendments commenced on the 1st of November 2017 and will therefore only apply to cladding installed on or after this date. Between WA, Western Australia, between July 2017 and June 2019, the Department of Mines, Industry Regulation and Safety Buildings and Energy Division coordinated Western Australia's statewide cladding audit. The scope of Western Australia's statewide cladding audit was limited to all Building Code of Australia's Class 2, 3, 4 and 9 buildings, 3 stories or greater, built or refurbished after the 1st of January 2000. These classes of buildings are considered high risk as they typically include places where people sleep, apartments, hotels and caretakers accommodation, for instance, or they house vulnerable occupants, hospitals, nursing homes and childcare centres, or they cater for high occupancy events, entertainment venues and public buildings. Building and Energy carried out the audit of 1,795 privately owned buildings that were identified as falling under the scope of the audit in relation to the building class, height and age. A physical inspection of these buildings identified only 475 with suspected combustible cladding. This was further reduced to 258 buildings following a preliminary risk assessment. A more detailed risk assessment resulted in no building identified as an extreme risk. However, 38 buildings were found to be moderate risk and 14 buildings were considered high risk. The affected buildings were referred to the relevant local government, permit authorities, for liaison with building owners and enforcement action. Building and Energy also assisted state government department, agencies and universities with coordinating the audit of another 1,914 public and university buildings, which were quickly cleared. 1,783 of these buildings went further review. Of the remaining buildings, 38 were found to require some type of remediation action. In the ACT, the government undertook detailed investigation of its buildings which contained combustible cladding in 2020. These investigations involved a multi-stage process that identified, reviewed and assessed ACT government-owned buildings, taking into consideration the type of occupant, use of the building, nearby ignition sources and firefighting challenges in the event of the fire. Remediation work have been either completed or underway on the 23 government-owned buildings found to have combustible cladding. The AC government has completed works on numerous public buildings across the ACT, including ACT housing, schools and colleges, grandstands, the National Convention Centre, and child and family centres. The following are a list of cladding materials that are making their way into the Australian market as alternatives to ACP and other combustible composite materials. Ceramics, terracotta. Ceramics are formed through the burning of clay. Most modern processes add several other components to the mixture, resulting in an extremely sturdy product which can take on any shape. Natural slate. With shades ranging from dark grey to black, natural stone facade such as slate gives sobriety and sophistication to any facade. In addition, the material adds thermal comfort and ease of installation for ventilated facades. The slate supports extreme temperatures, barely accumulates snow, has fire resistance, and is totally waterproof. In addition, because it's 100% natural, it has reduced environmental impact, and each piece is made by hand, without chemicals or additional treatment. Anodized aluminium. The process of anodizing consists of making an oxidized film on certain metals through immersion of an electric bath, in which the metal to anodize is attached to the positive pole of a resource of electricity, turning it into a node of the electrolyte. Render. The look and feel of rendered facades is familiar throughout Australia, and new technologies have been given to various synthetic renders. This concludes my presentation today. Obviously, there's a lot more information on this topic on the EEA website, which I recommend looking into. It talks into details of cladding remediation Part A and Part B of Project Remediate. Thank you, and have a good afternoon, good evening.
Thank you, Doron, for your presentation. I'd now like to welcome our second speaker, Cathy Inglis. Cathy is an experienced materials engineer with over 20 years of experience in the building industry and leads the innovation team in Brickworks building products across brands including bricks, precast concrete, masonry, roof tiles, and lightweight facades. Cathy is responsible for the research and development of new products, technical matters, and leading innovation to improve energy efficiency of operations and create sustainable building products. Cathy is on the National Board of the Housing Industry Association and represents the industry on several Australian standards. Please welcome Cathy Inglis.
Good afternoon, and thank you, Amanda, for that introduction. So today I'm going to cover a bit more detail about non-combustible facades and go into a bit of depth about the NCC and the changes coming in the 22 version. Also going to cover a bit of the testing requirements, and show you some examples of tests, because many people haven't actually seen what a non-combustibility test looks like. So cladding fires, as we know, are nothing new. And as Doron mentioned before, this week saw the 5-year anniversary of the Grenfell Tower fire. We've had lots of examples of various facade materials that have resulted in fires, and some examples here show a motel fire in Albury in 1999, which is fiberglass panels, which started inside on the 3rd floor and quickly spread up the outside. The Te Rapa Museum in Wellington, which was caught on fire during construction by a welder, and this was under construction using aluminium composite panels with extruded polystyrene insulation boards on the inside. And another material, the composite thermal insulation boards used on an apartment building. This one example's in Munich, but the combustibility of those, many of the thermal insulation products that are out there, and there's been numerous fires with those over the years. So as I said, this is nothing new. The Building Codes Board commissioned a fire performance report way back in 2000 to look at examples of fires, how they started, and what could be done about it. So a long time came before we actually saw the first changes, and it all did follow from the Grenfell and then the La Crosse building after that. But essentially now, I'm going to now talk about what's coming in the 22 version of the NCC. So the NCC 2022 Class 2 to 9 buildings, it's covered fire resistance in Section C, and the clauses now have all been renumbered. So I've got some examples to show you the clauses. So C2D2 sets out the minimum fire resisting construction for Class 2 to 9 buildings based on the number of stories in the building, to whether they're Type A, Type B or Type C construction. So Type A and Type B are required to be non-combustible construction. So in Part C1 fire resistance, in 2019, the performance measure CP1 was a building must have the elements which will, to the degree necessary, maintain the structural stability during a fire. So now in NCC 2022, this is now a functional statement. So the NCC is broken into, you've got objectives, you've got functional statements, and then you have the performance requirement. So the functional statement is, in 2022, is a building must be constructed to maintain the structural stability during a fire to A, allow the building occupants to escape, to allow for fire brigade intervention and avoid damage to other property. The functional statement 2 is a building is to be provided with safeguards to prevent fire spread. And that's one we're going to go into a bit more detail about. So preventing fire spread during a building fire, it's related on a whole lot of things. And you can see the list there. So it must be have elements to the degree necessary to maintain the structural stability, which is appropriate to the function of the building, the fire load, the size of the building, and all those things need to be taken into account when working out if your building will meet that performance requirement. So performance clause 2 is to prevent the spread of fire. So a building must have elements which will, to the degree necessary, avoid the spread of fire to exits, to sole occupancy units and public corridors, and in a building and between buildings. And this is, again, appropriate to the function of the building, the fire load, the number of stories, the proximity to other products, and that list of elements there. In the new 2022 NCC, you'll see this is a snippet out of the preview draft of the NCC. The final version will be released soon and then comes into effect from the 1st of September, depending on the states, each state authority and when they call up the things. But you will see there's a little box on the right which says 2019 CP2. So with them renumbering all the clauses in the NCC, they have put that little number of what the clause used to be in the previous version, so you can go back and you can see what's changed. But a lot has changed in this space. So the deemed to satisfy provisions that are in the fire section for C2D10 is the non-combustible building elements. And these are the deemed to satisfy provisions. So this is where a building of type A and B must have the following elements, and all their components must be non-combustible for external walls, for common walls, for flooring and floor framing of lift pits, and non-load-bearing internal walls that are required to be fire rated. And then it goes on to shafts and other things. But specifically, we're talking about external walls, so we'll focus on that. So that's the requirement. And that was the previous clause C1.9. So what's new? Now, I know this is quite small. You might have trouble reading it. But this is what's new in the list of what requirements, what building auxiliary items are allowed, and they've added to this list with a whole lot of new things. So previously, that first clause, there must be non-combustible for external walls, there was only several things that were exempt: gaskets, caulking, sealants, termite management systems, and glass, and damp-proof courses. The rest of this list, it now goes down to item Q, have all been added. So this now adds things like thermal breaks, compressible fillers, you've got waterproofing materials, paints, adhesives, packers. They're all listed there now as these now are elements of your facade that are not required to be non-combustible. And what else is new? That they've finally added in a list of materials that are non-combustible and they can use where you need to use a non-combustible material. So this has added concrete, steel, masonry, aluminium, AAC, and the list goes on: terracotta, porcelain, ceramic, stone, zinc, lead, bronze, brass. So they're all known non-combustible materials. But in the past, we always had the issue that because these weren't listed, people were asking for non-combustibility testing of a brick or of concrete or of terracotta tile. And we know those materials, they're known non-combustible materials. So it's great that the Australian Building Codes Board has recognised that, and these are now included as exempt items and can be used wherever a non-combustible material is required. There is still the list of materials that can be used where a non-combustible material is required that have limited or low combustibility. So this was the list. This is the same as the previous version, and these are plasterboard, fibre cement sheeting, and bonded laminates with the requirements of the bonded laminate, the thickness of each layer and the minimum adhesive layer, and that you've tested it to spread of flame and smoke development indexes. So that clause essentially hasn't changed, except the only thing they added there, bonded laminates, when they're used externally must be fixed in accordance with CD D15. So this requires mechanical fixing of bonded laminates to the external facade. They can't be adhesive fixed. So that's a new addition to that clause. So to meet the performance requirement of C1P2, the building, which must have elements to the degree necessary to prevent the spread of fire in a building, the compliance pathways to meet this is you have a performance solution, or you use the deemed to satisfy solution, or you use a combination of both, as you do with all clauses in the NCC. So first we look at if you'd use deemed to satisfy. So deemed to satisfy, I showed you before the deemed to satisfy clauses. So this means you can use a known non-combustible material from that list, which is deemed non-combustible, or you can have a test of non-combustibility to AS 1530 Part 1 that demonstrates that your material or product is non-combustible. Or you can use a product that is deemed non-combustible from that list of products with low or limited combustibility. So that's using the deemed to satisfy method. If you want to use the performance solution, you can develop a wall system and use a verification test method using C1V3, and that it tests the wall facade to AS5113. Or you develop a custom performance solution for the specific project and the system you want to use. So then you look at the testing and what it means and what it looks like. So non-combustibility testing to 1530 Part 1 is essentially taking a small part of your product right through the product. So it's 50 mils diameter, about 50 mils deep. It's got a small core in the centre where a thermocouple's placed in it, and it's sat in a little wire basket, and that is lowered into a furnace. So you can see on the image of the right, there's a mirror at the top that shows the red hot inside of the furnace. The sample on the left, this shows the basket, and it's lowered into the furnace. And the temperature of this test is at 750 degrees. So a material is declared non-combustible if there's no development of flame or excessive heat when the sample's immersed at that 750 degrees. So materials that do have some combustible components in them can still pass this test. If you look at that little sample there, you might see it's got extruded polystyrene as a lightweight aggregate in it. And that actually passes the test because as it's lowered into the furnace, the very exterior polystyrene volatilizes before it's dropped into the furnace. The rest of it is then protected by the cement matrix of the product. So it then doesn't sustain a flame and doesn't exceed the temperature required. So there can be combustible components in a product and will still pass the test because they're protected by a cement matrix or some other means. So you can see here the sample actually being dropped into the furnace. And this one, if your sample is thinner than the depth of this thing, you cut layers of it and you just build it all up and to make it to the 50 mil height that it needs to be for the testing. And then finally, when it's dropped in, you can see this is a product that's failed and it's sustained a flame. It's been dropped in, it's caught fire, and they've brought it out and it's still sustaining a flame. So that would be a product that would fail the test. It's quite a simple, easy test, but it has its limitations, particularly with multi-layer products and multi-compositional products of how you actually test it for that. And that's probably where using 5113 becomes a little more useful if you've got a product that can't be tested using this system. And once it's tested, you'll get a test certificate that they can look very different. But essentially what the test certificate will declare is if there was a sustained flame, what the rising temperature was over the time the sample was immersed, and it will declare them as deemed to be non-combustible. And the examples there show one from CSIRO and from Exova Warrington. So another way to demonstrate if you're doing a performance solution is to use the verification method C1V3, which is fire spread of external walls. And this uses the external wall performance test, which is Australian Standard 5113. So to get a wall to meet this verification method, you test it to that standard, and it's got to achieve a classification of EW, which means it's an external wall classification. If the wall has a cavity and incorporates cavity barriers and they've been included in the test, they must be then used. And if you use this test as a verification, as it's a verification for performance solution, you actually have to build the wall exactly as it's done in the test method. There's no variation to it. If you want to vary it, then another test would be required to demonstrate that that build-up system layers that you've put in your whole wall will be able to pass the EW rating. So this test was introduced in the amendment in 2016 as a means to comply for non-combustibility, and essentially it's the fire propagation testing to classify external walls of buildings. So I'm going to show you a bit about the test. It's essentially a wall that's nearly 10 metres tall. At various heights of the wall, there's a series of thermocouples to measure temperature, not only at the various heights, but also through the depth of the wall. So you have a series of thermocouples to measure the temperature at not just the external face, but also through the layers. So through your insulation, through your frame, right through to the whatever your internal lining is on the inside of your wall. The wall's built, when it's finally built, you can see in the far right picture, there's a crib of timber put in there that's set alight that is your fire source for the test. So once the fire's lit, you can see that it continues on until they test it for the period of time necessary till the box falls, the timber crib falls over and the fire goes out. So the wall test is also has a wing wall. So we know that the way that walls intersect and having a wing wall will affect how the fire goes. So that's why this test is done with a wing wall. You can see there's, apart from smoke damage, there's very little damage to this wall. And this wall was a test done on a cladding board product that was actually deemed already non-combustible because it had passed 1530 Part 1. So this was done just as an experiment to show that if you've passed 1530 Part 1, this product actually passed this test for 5113. And to pass 5113, there is 9 criteria that you have to pass all of them to receive the EW rating. So this is related to the temperature at a certain point after a certain time, and there's a measure, so the first one at 5 metres, you've got to be less than 600 degrees to pass it. And it goes on up the different, you must have no flaming, there must be no opening of the cladding, no spread beyond the specimen, and also no flaming debris, but also the debris mass is limited to 2 kilograms. So once you pass all of those, you get an EW rating, and then that wall system, as built, can be used and to demonstrate compliance to the performance measure for the building must not spread fire. So in addition to that, if you use that as a verification, you also have to add in the NCC additional sprinklers, and there's a few other requirements if you use that as your verification method. So just to show you example what happens after post image of the wall, you can see on the far left, the fire's gone out, the crib's been totally removed, and you've got some smoke damage on the wall. When the cladding boards were taken off, you can see there's brown staining on the wrap from the heat of the fire concentrated in that lower area. But when the wrap's removed, you can see there's no damage to the insulation or the frame behind that. So as a comparison, I'm just going to show you some examples of what an aluminium composite panel looks like in one of these tests. I'm sure some of you have seen this before. If not, there's plenty of images there's some on LinkedIn and some in Google. But essentially at fire with a polyethylene core, you can see at 5 minutes, which is the photo on the right, the flame's already up and you can start to see the aluminium starting to shrink and melt away. And finally, that's what it looks like after the test. And that test was stopped at 10 minutes and 21 seconds. And that's how much damage was to the wall. So that's what the significant issue with the composite panels. So just looking at some other 5113 tests to show you how other materials perform. So this is a test of fibre cement boards. These are 9mm fibre cement boards that are actually allowed to be used for external cladding. These have an exemption in the limited combustibility list in the NCC that you can use them. I don't think these products should be used for external cladding if they can't meet the 1530 Part 1 test or pass the 5113 test. Because what you can see here is that here's the initial photos of the boards on fire. This is what it looked like when the test was stopped at about 14 minutes. And you can see the significant damage to the fibre cement boards on the left-hand side. The photo on the right-hand side is during the test and the back of the wall. It's a bit fuzzy because you can't get close to it because of the fire. But when you blow it up, you can see that the fire's actually come through the fibre cement, through the frame and insulation, and is coming right through the plasterboard lining on the rear, which is the inner surface of your wall facade. So this product's allowed to be used, but it can't pass 1530 Part 1 tests or the 5113 tests. Just to show you some close-up examples of what the fibre cement can look like. This was some more simulated tests on a small scale showing a 5113 test with brick versus fibre cement, and that at the end of the test there's smoke and staining on the brick wall, but the fibre cement panel has cracked, fallen away, and you can actually see that the image in the middle shows the fire coming through the product right through to the frame and the backing of the wall. So another way you can demonstrate verification is they've included in the NCC 22, there was a preliminary bid in 2019, but in the NCC 2022, the new fire safety verification method, which is compliance with the performance requirements, is verified when the building is designed in accordance with the fire safety verification method standard, the performance-based design brief, a fire strategy, stakeholder involvement, and the required level of safety. Now, I'm not going to go into all that. This is quite an onerous way to demonstrate performance, that you've met the performance requirements, but it is an option to engage a fire engineer and to undertake this work if you've got a custom facade or something else that you can't meet the requirements any other way. This is one way that you can do it. And this involves in all the stakeholders doing fire strategies, having essentially a peer review of the documents to make sure that their building will meet those performance measures for fire safety. So external facades are much more than just talking about non-combustibility, which is what we've covered off today. Obviously, all of that needs to be combined with the appearance of your facade, structural adequacy, serviceability, waterproofing and condensation, thermal and solar transmission, acoustics, sustainability, and durability. So there's a lot of things that need to go together to get the facade right. And earlier this week, I was at the New South Wales presentation for Project Remediate, which is to remove the cladding materials off the ACPs, off buildings that have been deemed to have combustible claddings. And it's not just the cladding they're finding issues with. There's issues with incorrect materials used for supporting the structures, attachments. There's corrosion of the fixing materials and rails supporting the claddings. There's waterproofing, there's condensation issues. So there's many things that need to be addressed to make sure your facade meets the requirements it needs to do to perform as it should. So obviously there's some new measures coming into the NCC 22 around energy efficiency and combustibility. That document hasn't been released yet. It's due later in the year after the building ministers finalise what's going in for energy efficiency after reviewing all the RISs, and that will be then included in the 2022 NCC. Probably for call up a little bit later. It looks like they're going to give a longer lead time for those measures to be, people to get used to them, get them included. So there'll be a bit of a transition time, which is supposed to be announced fairly soon, what that transition time will be. So all those things need to be looked at. So finally, to finish off, I just thought some options when you're looking at non-combustible facades and trying to meet a lot of those requirements. You've got options around ceramic, and terracotta facades. And now that they're listed as deemed non-combustible, it's great now. You don't have to provide the test certificates, even though we've got them all because we tested them to get through the last few years, that you can use them. So terracotta facades on aluminium or steel hanging systems can meet those requirements of non-combustibility, but also give you durable and long life wall claddings that have virtually no maintenance and will be colour fast forever. And with Terracard, the good thing is that it has a 100-year warranty on the tiles for colour fastness and durability. So just showing another example there at Sydney Uni of the Terracard system in use. And this is a hospital in Adelaide. This was prefabricated. So the building elements of tiles or bricks on metal hanging systems have the ability to be prefabricated and to put on your building, so you can control the layers and control actually the build-up to meet your thermal and condensation measures a little bit easier if you can prefabricate the units. Using thin brick on railing systems, this isn't new. It's been around for a while. The Brickworks will be launching a brick on rail system later in this year, so keep an eye out for that one. So thank you very much for your time and look forward to answering all your questions. Thank you.
Thank you, Cathy and Doron, for two great presentations this evening. It's now time for you to get involved, our audience. And please, if you'd like to send questions through to our speakers through the YouTube chat box, we've got about 20 minutes for questions this evening. Thank you also to everyone that sent through questions when they're registered for tonight's event, and we might start off with a couple of those. And Cathy, we have a question that's come in from Michael, and Michael's watching from New South Wales. Good evening to you, Michael, asking, redesigning the waterproofing of a facade with a performance solution, which is not 100% with Australian standards. What's your opinion re the procedure through FP 1.4 and your opinion re the risk liability of the facade designer and certifier with performance solutions? Thank you, Michael, for that question. Cathy.
Thank you, Amanda. It's an interesting question because the way to demonstrate that you meet the performance requirement for weather tightness and to prevent water ingress into a building is the verification method is the test. So that's the test to AS 4284, and the NCC part of it is slightly different to the standard 4284 test. You've got to build a wall that has an internal corner, external corner, a meter box, a roof junction, and several other things. So you do a weather test on the whole wall system. Now that's great for a single layer product, and what's tested can be used then to demonstrate your performance requirement. However, the good thing about in 2022 NCC is they've actually declared a couple of materials that are deemed to satisfy to meet that performance requirement for weather tightness. So they've actually included masonry, metal panels and aerated concrete as three materials that you can use to meet the deemed to satisfy provision, which makes it a bit easier. If you don't have a test of your materials, then it goes back to getting a performance solution another way, and then you've got to go back to the NCC evidence of suitability, how you'd meet that performance requirement. And for weather tightness, that can be quite difficult looking at the detailing. Thank you.
Thank you for that, Cathy. Doron, over to you. We've had a question coming from Fiona, and Fiona's in Victoria asking you, Doron, are there any retroactive components of the code / government requirements? Doron.
Sorry about that. Thank you, Fiona, for your question. Yes, as outlined in my discussion, there is retroactive component of the codes. The whole process of rectifying buildings and removing the claddings on the buildings is all retroactive. So there is obviously now a ban on composite panels. However, the government with Project Remediate and the Victorian government's project to replace the cladding on the buildings has started. In New South Wales, we're at the forefront of the major project, Project Remediate, whereas in ACT and in Victoria, most of the buildings have already been completed. So that's basically it. There's a lot of information on the Victoria Government website regarding the amount of buildings that have been completed in this process, as there are obviously in the New South Wales and the Canberra Government websites. Thank you.
Thanks, Doron. Cathy, do you want to comment on that at all?
No, I think like Doron said, a lot of it's been covered in the method and how to do it and what needs to be done. I think one of the things, though, that was highlighted at the Project Remediate session was, though, that when the buildings were identified with combustible cladding, when they removed that, how many other issues were present. So issues with weather tightness, corroded fasteners, corroded railing systems, inappropriate insulation. So there's a whole range of measures that they identified. So it wasn't just a problem with the combustible cladding. There's actually a whole lot more with that construction as well. So I think it's something that if you do go to rectify any building that you're removing cladding, flammable cladding or whatever else it might be you're removing, you've got to look at the whole wall system. There's no point just putting something back up on a substructure that's not going to continue to perform and going to fail at some point later on.
Okay. Thank you, Cathy. And just sort of staying with you, Cathy, for a moment, Engineers Australia will be running our Climate Smart Engineering Conference, and you touched a little on this in your presentation. From an environmental sustainability point of view, where do you see this heading in this particular area?
Thanks, Amanda. It's an interesting question because this is where it comes a balance of the products you select, the durability of them, the maintenance over time, and how long they'll last on a building. The biggest thing with sustainability is to build something that lasts for the longest period of time with the lowest maintenance. So that's obviously increases the sustainability of the building. So you want to look to products that are going to last a long time and have that durability performance and not need replacing after 10 years. And if you're doing that with your external cladding, you want to do it with, make sure that your layers in the building have met that as well. And that was another thing that Project Remediate brought up as well, about the warranty periods for the products that are selected to make sure that they're going to meet the time frame for a building. You don't want to be building buildings that you have to be doing significant maintenance and replacement of cladding products after 10 years or 15 years. You want to be able to build them to last much longer, and that's going to increase the sustainability. Then you look at how the products are made and make sure that you can essentially source products that are made in a sustainable way, or, there is limited products made locally, but there are some. So to look at those things, which improves the sustainability as well.
Thank you. And we do hear a lot, and we have talked about in the thought leaders about facades that have got a lifespan of 15 years. Doron, what are your thoughts on the environmental implications as we move forward? I might move.
Again, sorry about that. So there are two issues with the existing cladding. Where does that all go when it's been removed? Hopefully not into landfill. And secondly, obviously the environmental impact of the building works that need to be carried out now as well on the buildings. The removal of the cladding, all the sarking material, all the other materials that are going to be replaced need to be considered. Well, that's all what process is in place to relocate that material. Hopefully we don't find it on other buildings. I think that's a major impact that we will have with these materials.
And I think that sort of picks up what Scott, good evening to you, Scott, who's watching from Western Australia, who did ask you the question, Doron. What procedures, policies do you recommend for the removal of an existing combustible facade?
Good evening, Scott, and thank you for the question. There is an excellent document issued by the Government of Western Australia. It's a guidance note on the fire engineering assessment of external cladding and the whole process of what needs to be done in WA for that. So there is quite a lot of information on that site. In addition, there's obviously the documentation issued by the Society for Fire Safety Engineers of Australia, EA, Engineers Australia, regarding the process from A to Z of how a building should be assessed and what should be done as part of the assessment of the material that is on your building. So that's where you should be able to find some more information on that matter.
Thank you for that. That's great, Doron. And over to you, Cathy. We've got Amy. Amy is watching from Queensland. And Amy, and we do get asked this question a lot, is this system applicable to residential buildings as well as commercial?
Thanks, Amy. I presume you talked about the cladding systems that are available. That was the image that was on the screen holding slide, which is our Facade system. And yes, that can be used on residential projects and has been used on many of them. So there's certainly plenty of examples if you go onto the Facade website to look at it. But a lot of the cladding systems are at a low enough price range to be used on residential cladding as a residential cladding system. Some of the new ones that are coming up, the brick on rail, etc., they'll be really good for residential applications as well.
Thanks, Cathy. And Doron, good evening to Colin. Colin's in New South Wales. Asking you, Doron, how do we deal with gaps between fire-related concrete structure and non-fire-related facades? And he goes on to say, how is it possible to verify the performance of the joint? Thanks, Colin.
Very difficult question, but good question. So yes, as we have been discussing throughout the night, and Cathy has specifically discussed, is that the facade has to be looked at from the external part of the wall to the very internal part of the wall. So it's not just the area that, the gaps. So in order to understand what is behind the cladding material, we have to remove the facade material, and then we can have the actual facade, the ACP or whatever material is in there, and then slowly look our way into the building. So very specifically, a facade is not just the cladding material, it is everything from the external part of the wall, the cladding, all the way to the constructional element of the building. And all sections of that need to be assessed as part of the replacement of the cladding material on a building.
Thank you, Doron. Thank you for that. Moving over to South Australia, and we're going to talk a little bit about maintenance. We have a question that's coming from Paul to you, Cathy, predominantly, asking, is there any maintenance to the incombustible facades? And what is the service design of the facade?
Thanks for the question. The maintenance of the facade will really depend on what is selected. So in the range of products that are available, so if you pick something, a terracotta, a brick facade, they've got very low maintenance because of their long life and durability and longevity. Essentially all that's needed is a wash down every now and then with those sort of products, because they're actually made, the colours fired into them. And you've seen examples of brick and clay tile buildings around that have lasted for thousands of years. When you get to the maintenance of other non-combustible facade cladding materials, some of them need a bit more work than others. There are now non-combustible renders that are available. They're going to need maintenance and potentially repainting of the renders at certain periods of time. They're also going to need checking. Any facade cladding that actually has sealants for joints, then you get into whether if it's a sealed or a rain screen facade. If it's one that's sealed and it's got sealants, that those sealants over time will need to be checked if they're being depended on for the weather tightness. So it really depends on what material you pick. Some of the metal facades, they're going to have quite long life and low maintenance as well, depending what coating's on the outside of them, what the durability of that is. But it's always good to look at your distance from the coast when you're picking those, so you know that you've got something appropriate to the exposure classification you're building in, so that it's severe marine or marine environment, or just an inert environment where then it's not as critical for corrosion as well. So there's always more than just non-combustibility in the relate for the maintenance side as well. It's you got durability related to your exposure zones.
Thanks, Cathy. And I just want to put a future lens on now as we look at this topic. And starting with you, Doron, from your perspective, what would you say is going to be the key trends in this area of non-combustible facades in the coming next few years? What do you think will be the priorities for the different stakeholders?
The different stakeholders, obviously, if we start with the residents of the residential buildings and the owners of these properties, I think their biggest concern, obviously, will be the cost of replacing these materials. Yes, New South Wales and Victoria have offered interest-free loans. However, interest-free loan is still a loan, and people need to take money out and add that to their building, to their cost of their property. It's an unfortunate system that we can't go back and try to find the responsible person or entity that has allowed for these materials to be installed on endless amounts of buildings in Australia. So that's obviously going to be the big ticket item. Is people. I've heard of people having to fork out over $200,000 in addition to what they have on their mortgages to rectify buildings, and that always has put a stop to the projects of getting the work done. And obviously that is increasing the risk because the material is staying on the building. Yes, more and more people are aware that the building is cladded with a combustible material at a certain level. I think also the issue is that we haven't heard anything back from any of the jurisdictions regarding, is it at the moment we've allowed for, and I discussed this in my project, which is the 8% rule. At the moment, most of the governments are replacing any cladding that was notified that was above Category B under the ICS, the Insurance Council of Australia's level. However, is it going to change in the future? And what happens to the buildings that have already gone down the pathway of making this change from and installing a material that now, after we've been educated more in the process, is that cladding material now also deemed combustible and needs to be replaced? So there needs to be some definite conclusions in helping us engineers making those decisions. Is this suitable material, yes or no? Because it is going to open up another door in the future. I think they're the major issues that need to be addressed now before we proceed.
Thanks, Doron. And Cathy, from a materials, a manufacturing perspective, what do you see are the key trends going forward?
Yeah, I agree with Doron that it is critical. We don't want to end up with another material that's on buildings that in a few years we're going to have to come back and have the same issue with. It might not be quite as bad as an ACP with high polyethylene coring, but it could still be a product that is not suitable for the application it's using. And my example is showing that fibre cement sheeting that significantly fails both the 5113 test and the 1530 part 1. So I just can't see how it could be a sensible material to start putting on buildings that need to have non-combustible facades on them. Certainly has plenty of other good applications, but I don't see that's one of them. And I just don't want to see building owners and residents and things going through this same issue in a few years' time and based on a material that's been selected that maybe not be suitable for that application. And it's a really critical thing that you look at the selection of materials for the appropriateness of the building, and that's that whole long list I put in one of my last slides. And it's not just non-combustible; it's everything that you put it together to get a facade that's going to perform well. And the biggest issues are that probably more damage than non-combustible facades have caused in Australia. We've had one fire on a ACP building. We have many buildings that have moisture problems through inappropriate weather tightness detailing, leaking. We got mould. Those things are actually got significant rectification costs as well. So as you go forward and design new buildings, those things are really critical that they're addressed, because that's going to be just as much issue in the future.
Thanks, Cathy. And for moving back from these stakeholders to come back to the engineering community who are watching this webinar tonight, just starting with you, Doron, you did touch on that just recently. Obviously, this has been a very topical issue. There's been a lot said about it. There's been a lot talked about as to the role of the engineers here, the role of fire engineers when fire engineers get involved. Doron, what advice would you give to our engineers, and particularly to our young engineers starting in this field?
First of all, get insured. Make sure that your insurance policy does allow you to work on cladded buildings. That's not an issue. It's not an easy hurdle to overcome. Inform your insurance company on each building that you are working to make sure that they are aware that you have worked on that building and that you have been insured, and that specific building has been assessed properly by a fire engineer or other. I think that would be the starting point of my work. Also, actually do a lot of research on the different types of cladding materials that are out there that are alternatives. Within our company, we are now not allowed. We are now advising all. We are going back and advising all our clients regarding the 8% rule, which I just discussed. I think that needs to be assessed in greater detail because non-combustible is non-combustible and 8% is combustible still at a certain level. So that is something that we need to consider. And again, it is on the strata and the executive committee, once they are informed of this potential risk, that's on them at the end of the day, because their information has been transmitted to them. They should be looking at what they do have on the building, and is it going to be a problem in the future? I'm not sure, but at the moment, it isn't. But again, like Cathy and I said earlier, it might be. So my main concern for the engineers working in my office and doing the assessments on these buildings is be open, have a stakeholders discussion. Obviously, engage with the fire brigade when necessary. Engage with all the other stakeholders, strata, engineers on site. Engage with the executive committee. Have an open conversation regarding what is on their building, and then together make an informed decision of what needs to be done.
Thank you, Doron. And Cathy, Doron's just mentioned key stakeholders. I know that Brickworks pride themselves on the quality of your products. If you were giving some advice to our young engineers, what would that be tonight?
Quality of products, but also understanding the certification and testing that goes with those products. So if you're following a deem to satisfy, then you've got that path through the NCC. If you're using a performance solution or a performance combined with a deem to satisfy, then you need to demonstrate that your product is suitable for that application, and that comes through the testing and certification of the products. So many times we see products selected that don't have the right testing, or they're not tested to the right standards. They're not appropriate for that building. But sometimes people don't understand the test reports because they're long, they're complicated. But understanding what you've got for the product you've selected is critically important. And just for New South Wales, and I don't know if the other states are going to follow this, but through Project Remediate, any product that goes on those buildings, they're really strict about the documentation, the testing, the certificates, the warranties offered. And that's also going to come through the building assurance framework that New South Wales Construct are putting in place about who built the building, what products are used, what does the documentation and the quality of that documentation look like. And that's going to go into that assurance of how they're rated. So it's going to be picked up more and more, but I think that's one of the really critical things. And when I talk to a lot of engineers, architects, builders, they often don't understand the testing and certification that they need, or what they're looking at from what they've been provided. And it's often specific to products. It's not generic. If you've got a test certificate for one sort of metal cladding, that doesn't mean that can be used for all claddings of the same material, because they've been tested for that specific product. So really careful. That'd be my advice, to look at certification and testing appropriate to what the product's used for on your building.
Thank you, Cathy, and thank you very much. We have run out of time this evening, and I want to join me in thanking Doron Levy and Cathy Inglis for giving up their time tonight to deliver these presentations. I'd also like to thank Engineers Australia's industry partner for their ongoing support, and if you'd like to see more in this series, follow the link in the description box below. As always, we're looking for your feedback, what you want to hear more about. So if you could take a couple of minutes to complete a short feedback form in the feedback box below. I also just want to let you know that Engineers Australia, to further support industry and support industry deal with high-risk flammable cladding, we've released 2 training courses. They're brand new on cladding remediation through our training organisation, Engineers Education Australia. And these courses have been designed and delivered in partnership with the Office of the New South Wales Building Commissioner in order to improve the standard of engineering practice. Available to complete online within a couple of hours, the focus of the course is on defect prediction and identification, remediation analysis, and actions for prevention and resolution. So certainly worth a look. Thank you again for joining us, and we very much look forward to seeing you at our next Thought Leaders event. Thank you and good night.